right here. Let's say we have a circuit with a current source of 3.1 ampere, and then we have a resistor, 2 ohm resistance, actually 2 ohm resistance, and let's say we have 5 ohm resistance right here, and then we have a 1 ohm resistance here. And let's say we have another current source that is given like this, negative 1.4 ampere. So whenever you have a current source given like this, if you have a current source given like negative 1.4, you can actually flip the arrow to the bottom to top and make it positive. So here I'm gonna do that. I'm gonna make the arrow bottom to top. I make this one positive. Okay, now this is the circuit we have, and let's say the question is asking us to find out the current. Let's say they're asking us to find out the current I1 and then current I2 and then current I3. How can we do that? We can try KCL. Let's try KCL and see if it works. So if I apply KCL at node 1, let's say this is a node 1 and this is node 2. So first time I'm applying the KCL at node 1, KCL at node 1, and KCL says sum of current is equal to 0, or sum of all the current is equal to 0, or the sum of current in is equal to sum of current out. I'm going to use the sum of current in is equal to sum of current out. So if I use that, we know this 3.1 ampere is entering this node, so this is going to be positive 3.1, actually 3.1 in the left side, and then whatever the current going out is going to be here. Here we have I1 right here, and then also I2 exiting the node, so I put the I2 right here. So this is KCL at node 1. This is the equation we derived. Now we can use the KCL at node 2. KCL at node 2, and here we had to again look for the current in and current out. I2 is entering this node. Again, summation of current in is equal to summation of current out. I2 is entering this node, so I put the I2 right here, and this 1.4 ampere also entering this node, so I put the plus 1.4 here, and then I3 is exiting this node, so I put this one other side. This is our second equation. Okay, if you look at these two equations, we have how many unknown variables? Here we have two of them, right? So if you have two of them, we cannot do directly anything. We have to see if I can combine with this and do something. But here also I have two of them. But if you combine these two together, there are three of them. So when you have two equations and three unknown variables, you cannot solve it. You can try anything you want, but you will not get the final answer. So we have to do something else. What we can do right here is, if you look at the voltage here, if I take the voltage at here is V1, and if I take the voltage right here is V2, then I can write this I1, I2 and I3 in terms of voltage. So we are going to have two unknown variables. So let's actually do that. Okay, to do that I have to get rid of these two because I need some space. What I'm going to do, I'm going to copy this equation 1 and equation 2 right here and then continue. The first equation we have is 3.1 is equal to I1 plus I2. I put it in a box like this. And the second equation we derived from KCL is I2 plus 1.4 is equivalent to I3. Okay, these are the equations we are going to need later, but let's write the currents in terms of voltages. I'm removing this. Okay, let's look at the current I1. If we have voltage here V1, it represents the voltage difference between this and the ground. This is a reference. This is a reference. This is ground 0 reference. So if you have a V1 right here, it means the difference between this one is V1 minus 0, so that's going to be V1. So if you are writing current in terms of this, we can actually use the Ohm's law. Ohm's law says V is equal to I times R. And if I represent one in terms of current, this is going to be I is equal to V divided by R. So if I apply that one for I1, I1 is going to be equivalent to the voltage here, that is V1 divided by the resistance, that is 2 ohm. And this is our I1. Now let's look at I2. I2 again, the voltage here is V1 and the voltage here is V2. So here we have to be careful because this is not, for this one we had to do the voltage difference. We have two different voltages. If I apply Ohm's law, I is equal to V divided by R. This is what I derived from Ohm's law. Here we are going to have V1 minus V2 divided by the resistance, that is 5. That's the one going to be equal to I2. Okay, we derived our second equation. Now the third one is I3. Again the same equation, V divided by R. Here we have the V2 voltage and the resistance is 1. So that's 1. So the final answer is I3 is equal to V2. Okay, now we have these three things we derived. What we can do next is we can substitute this I1, I2, I3 in these two equations we derived from KCL before. And then if you do that, we only gonna have two unknown variables. And if you have two unknown variables and two equations, we can solve for it. So let's bring this one into this equation. If I do that, the first equation is going to be 3.1, and then instead of I1, I'm going to write V1 over 2. And instead of I2, I'm going to write V1 minus V2 divided by 5. Okay, this is our equation number 1. Let's write the equation number 2, I2. I2 is V1 minus V2 divided by 5. And then we have 1.4. And then we have I3, that is equal to V2. Okay, this is our equation number 2. The next thing is we have to see, like, when we substitute, can we get rid of something? We can do the elimination. Here, if I eliminate which one, that will be helpful for me to find something. Let's look at this. So first we can actually simplify this one in a better format so we can deal with this easily. Like if we multiply this one with 5, we can get rid of the 5 in the denominator and make it simpler. So let's do that for this one. Or 10 is better because this one becomes 31. Okay, let's do it by 10. I'm going to multiply the first equation by 10 and bring it here. I'm going to get rid of all these things here. Okay, if I multiply the equation 1 by 10, I'm going to have the equation that is 31 is equal to 5v1. And then here, if I multiply by 10, this is going to be 2 in the numerator. So this is going to be 2 times v1 minus v2. And this is my new equation 1. And I can even simplify this one furthermore by expanding the bracket. Let's do that as well. So here, if I expand the bracket, 31 is equal to 5v1 plus 2v1, and then 2 times negative v2, that's negative 2v2. 5v1 plus 2v1, that's going to be 7v1 minus 2v2, that is equal to 31. Okay, so this is my new first equation. Now here I am going to do the same thing. I'm going to multiply this one also by 10. So I'm showing this multiply by 10. That's how I derive this. Okay, I'm also going to multiply this one by 10 and derive a new equation. Let's get rid of this here. Okay, So if I multiply this one by 10, what I'm going to get? I'm going to get 2 times v1 minus v2 plus 14, that is equivalent to 10 v2. And I can expand this one and simplify furthermore. Like this is 2v1 if I multiply, and 2 times negative v2, that's going to be negative 2v2 plus 14 is equivalent to 10v2. And if I bring this negative 2v2 to the other side, that's going to be positive 2v2. So this is going to be 10v2 plus 2v2, that's 12v2. So we are going to have, let's bring the, let's keep the numbers in one side and bring the other things to the other side like this. So it's going to be easier to simplify. So if I keep the 14 this side and take the other things to the other side, 10 plus 10, actually 10 plus 2v2, that's 12v2. And if I bring the 2v1 to the other side, that's minus 2v1, that's equal to 14. Okay, now we have these two equations simplified. The next thing we can do is we can try to get rid of something and solve for it. Okay, if I add or subtract or anything which I can get rid of. Okay, so first if I multiply this equation 1 by 6 and add with this, I can get rid of this v2. Let's do that here. Okay, I'm gonna get rid of this equations here. Okay, so first I'm gonna multiply this 1 by 6 to bring it to negative 12v2. So if I multiply the whole thing by 6, I'm gonna get 7 times 5 35, 7 times 6 42. So this 42 v1 minus 12 v2, and then 31 times 6, 31 times 30 times 5 is 150, so 155, 155 plus 31, that's 180, 186. So this is going to be 186 right here. Okay, let's add this one with this. This is minus 2v1 and then plus 12v2 plus 14, and if I add them together, this is minus 2v1. If I add them together, this is going to be 40v1 is equivalent to 200. So if 40v1 is equal to 200, then v1 is going to be equal to what? 200 divided by 40, that's 5. 5 voltage is the v1. Now the next thing is we can substitute in the simplest form and solve for v2. Here the simplest formula I can use is this one, because this is only 2v2. So let's use that. Okay, I want to get rid of something here. Which one is good? Let's get rid of this. Okay, so let's put the equation again. This is negative 2v2 and I want to arrange this one in terms of v2. So I bring the 2v2 to the other side. So 2v2 is going to be 7v1, and if I bring the 31 to the other side, that's going to be negative 31 here. So if okay, let's substitute the v1 value, that's 5. So 2v2 is going to be equivalent to 5 times 7, that is 35, and then minus 31. 35 minus 31 is 4, and 4 divided by 2, we are going to get 2 voltage. So v2 is equal to 2 voltage. Okay, so we have found out v1 and v2. Now we can find anything we want. So let's go back. We are interested in current, right? We wanted to find the current. So let's go back and find out the currents. Okay, now again let's use the voltage formula, Ohm's laws, and find out the currents. The first one, Ohm's law is V1 is equal to I1 times R1, and therefore I1 is equal to V1 divided by R1. And V1 we found out that is, where's that? It was 4 voltage. Okay, I erased it. 4 voltage, actually 5 voltage. 5 voltage. So we have the V1, 5 divided by the resistance across this, that's 2 ohm resistance, and we are going to get 2.5 ampere for the I1. And now we can solve for the I2. I2 is equivalent to voltage difference, that is V1 minus V2, divided by the resistance in between, that is 5 ohm resistance. V1 is 5 and V2 is 2, V1 minus V2, and then divided by 5. 5 minus 2, that's 3, 3 divided by 5, that's equal to 6 divided by 10. So 0.6 ampere, that's our I2 value, 0.6 ampere. Now let's look at the I3. I3 is equal, we found out the formula like I3 is equal to V2. There's a formula we derive, I3 is equal to V2. Therefore, V2. Therefore, I2 is going to be equal to 2 ampere. And that's it. That's how we can solve and find the currents when we have 3 unknown variables and stuff like that. I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.